Okay, I think we're ready for another chance here. Just a little bit of reassurance. When I look at this plug and the way the last person wired it, okay, he's got a black wire where I believe there's a ground. Okay, and then where I believe there are two sets of filament wires, he's put in two orange and two yellow. And then where I believe there's the two high voltage lines, he's put in a red one and a brown one. So to me, that wiring arrangement actually reinforces everything that I've come to believe. I'm really feeling 100% certain about that. Okay, are we ready to go again? Yes, I would say so. I'm going to put this guy here. A bit of a longer view of things. Antenna. Okay, so we're going to try this on an outdoor antenna again. But I do have the signal generator warming up, so we'll switch to that after. Last time around I didn't like having this operating for any length of time because I was uncomfortable with the fact that it wasn't working and seemed to be drawing power, but didn't seem to be, it just seemed to me that it wasn't a wise idea to keep it operating. This time I'm going to feel a little more comfortable about that. Last time too I noticed this light was quite dull, which worried me. This is on the same line as some of the tube heaters. One of the tube heaters, one of the tubes. One of these tubes takes 6 volts. I think it's that guy, but I'm not sure. I can't remember. Okay, any reason for dilly-dallying further? Volume down. No need to dilly-dally further. Okay. Power on. I'm going to have my eyes on that a dim light bulb. Came on quite bright. Dulling down. You know what? Maybe that's what happened. I had such a restriction. I never got enough voltage into this guy. Easier to move the camera. There. And the radio. 63 volts, yeah, that's crazy low. So if you look up at the light, you kind of see that the element is glowing up here. 63, got to be too low. That would explain the dim light here, and everything's explained by that. So, okay, so for whoever it was who suggested that, go get yourself a cigar. Okay. Of course, we're not hearing anything, so I'm going to bump up the voltage here by screwing in the other dim bulb. This is going to jump it way up, I'm sure. Everybody ready? Something going to happen? I got to reach right across here to do this. Shh. 94 was still low. 94, okay, and the total power draw 30 watts. 30 watts. 30 watts. Something doesn't sound too good. Looks a lot better now. Okay. Volume up. Tuning. Tuning. Ah, sounds ridiculous. I'm not going to hear anything there. Okay. Could be these resistors here. I don't hear anything. I think you'd hear a little crackling or something. That's pretty good. That tells me audio signals getting from here over. It's a front end thing. This volume control doesn't seem to actually fix anything. It doesn't seem to change the volume at all. Okay, let's pump in a heavy signal here. Make any difference touching the antenna wire at all. Okay, I'll tune this in the middle. Well, it pretty much is in the middle right now. There. So that's got to be around 900,000, something like that. We're right around 900 right now. Did this before, didn't I? Got nowhere. Get anywhere here. Now these are basically a series of radios. 1, 2, 3 radios. If I could inject the signal in each one, like start here and start working my way back, maybe I can get somewhere. I think that's just a matter of pumping it right into these plates. I think. Do I really know that? No, I don't really know that. But let's give it a go. Somewhat crazy idea here. These are grid resistors. I should be able to feed a signal into those too and get something coming out, but somewhere in here it switches to audio. I think it's this tube. Oh, hey. Not so crazy an idea. not so crazy. Let's tune the radio and see what happens here. So that tells me the frequency we're tuned to. It's very hard to hear. Volume's having no effect because the volume is nothing more than a resistor on the antenna. If that's the case, then I should be able to feed a signal in bypassing this resistor too. Okay, so where's the radio? Still hear it. Can you hear that? It's 1,000 hertz tone. Barely. Should be louder here. Only at 86 volts here. Oh, 96. Ah, you think that would be enough? With all that static crashing, man, it's a little nerve-wracking taking her up to full. Crazy stuff there. Don't do that. A bit of a gamble involved in that. So we can get the signal here. Nothing loud about it. I wonder if one of these, what if this is open? This control is doing nothing because it's bonkered. Why, if I come back one tube, can I not get it? It could be voltage. Well, okay, it's been running along a fair length of time. The static crashes have not changed particularly. They just keep doing what they're doing. Let's just do this. I'm going to shut the power, pull this tube, switch the power back on. We continue to hear all that static and crashing. Things have gotten very quiet, haven't they? No more crackling. Oh, spoke too soon. A little bit. Quiet now. That's pretty good. Yeah, it's 15% modulation of that tone. Okay. I don't, why it's just started working. Let's go back. Doesn't like that. Doesn't like the going back thing. Let's try down here. So it looks like we're working okay out of this stage. Wait a minute. I didn't pick it up again. That's not right. Going the wrong way here. Okay, so maybe hooking up this clip lead is changing the resonant point of the circuit, but it looks like this radio is tuning from the very bottom of the AM band downwards a bit. That's what it looks like. And it could just be because of what I'm doing here. Let's go back on the antenna. Let's go on the real antenna here. Okay. Everybody listen now. So that should be, actually that's the high end of the band. None of this is making much sense. So we would have this radio right now tuned to around, this would be around 670, say 700. Nothing. If it's tuned around 700, as far as it's concerned, it's tuning four, way off, way off. Let's do this. Okay, connect this. A high signal, I'll just try to hold it in proximity. That's not going to work. Trying to get a signal into the radio without disturbing, without hooking right onto these plates here. I'm not sure this will make any particular difference. Nothing getting past here. Of course, the radio's actually, although it, it could be happening. It could be this stage is way off and tuning at 500 when the other stages are tuning at 800. And it's just 800, 500, you can never get all the way through. You could get through if you jammed in a strong enough signal, I would think. Something would show up. Why would this not be tuning right? Oh, you know why? I've got this. Okay, you knew why all this time. I gotta put that can back on. Okay, power off. Power off. Power off. Let me get the can back on here. Okay, so I've got the nuclear blast dome back on here. That was probably the reason why it was tuning way off. Okay, that's back in. Connect back like that. I think we're ready for another try. Okay. Volume down for what it's worth. Okay, just a moment of silence there before I hit the switch. Okay, we're on restricted power again. 199, 98, going down a little bit. Okay, so we're hitting it with a signal out of band here. 600, 750, 670, 600. Come on, baby. No. It's a great big no. That's a strong signal fed into the antenna. Ooh, I didn't have this turned up. Let's just try that. Now that's bypassing this volume control here. Jeepers. 600. So this area. Why? Okay, let's move it forward. Just going to turn down the signal strength. We'll try right here again. Up on the signal strength. Okay. This is supposed to be tuning up around 1400. You kind of see there in the video. We're only at 600. What happens if we go up there? Can't make it this way. $1,400. Here we come. Let's put up full strength here. Okay, so ooh. What's going on there? It's kind of very subtle changes in its reception. Oh yeah, well let's put it up at this end. There's just nothing sharp about that. Getting nowhere. Rapidly getting nowhere. Let's, oh wait a minute, did I get this on to full? I never did get it on full. So it's 100 volts here, but let's turn it right up. Hum has become more distinct. 55 watts. I can't imagine that's going to suddenly make this radio work. Kind of hear the tone coming through all the time. What's the problem? I have a hard time understanding how it could even do this. How can it resonate so far off? Power off. Now, let's take a look at these grid leak resistors here. Tube. That's a problem. Oop. What's going on there? How did I get a 0? That's good. That'll help it. Okay, clean these up. And this just isn't making contact. See anything inside there? I don't see a thing. Typically these have carbonized paper strip in them to achieve the very high resistance, but that makes them pretty fragile. Or is there a little tiny wire in there? I don't think that's how these work. Well, this looks like an empty glass tube to me. How did I get those occasional low readings on it? Let me put it back in the clamp and read on the clamp. That might be a smarter way of doing it here. Put this here. So often I see a reading on there. It's pretty convincing that it's open circuited. We're on 200 million ohms on my meter now. And now it wants to say. Try and explain that. On the 200 scale, I get a reading. On the 200 scale. Hey, you think you're learning your lesson, Jim? It is. 1 megohm when read on that scale. Read on this scale. There it is again. Okay. Well, it's definitely conductive. The reason these are up above where people can get at them like I'm getting at it is because there was always trouble and concern with these. And you might want to try different values of resistor. See if you can't clear up the... Again, it's conductive. 5. Around 5 megohms. Test it. Grid leak. 2 megohm. But I got it at 5. What if these are switched? 2 megohms. Oh yeah, look at that. Oh, I got my fingers on it. Hang on. Yeah, with me involved. .5. I just don't see how these can be the problem, really. I do have a bunch more somewhere. Well, we should take a peek at the schematic and identify this point into which I can jam a signal and get a result. It's on the last tuning capacitor. Here we go. Okay, so last tuning capacitor in is right here. There's the grid leak. I believe 25, grid leak 3 megohms, right here, it says right here. This one we're measuring a little higher than that. 74, a lot of these parts, this is a little tiny short part list here, and I didn't list a lot of these parts. So that's into the grid. It's the capacitor resistor combination that derives a bias on these tubes. So I'm feeding the signal in, I would say 1, 2, 3, 4th one on the, I'm feeding it in right here. So it's going right into the grid and producing the audio we can hear. It's not even going through a tuned circuit. It's kind of weird. The tuned circuit's, well, it is kind of. The tuned circuit's kind of behind it here. Where? Well, all these coils can have effects on the tuning in here. What's this guy doing down here? One every time. So we think of this as a transformer, and maybe this is the coil against which this tunes. I should feed in audio here, really, at this point. Okay, so where is the actual detector? Would be this tube. Okay, so I'm feeding in ahead of the detector. Yeah, this is the first audio amp here. So, if I did feed audio onto this grid, I think it would come out of the speaker. But I think it's really intended to have RF and then the detector actions occurring right in this tube. Output is shot onto this tube, the audio output. So what's going on here? That feed it in here, we can kind of hear it's tuning funny. Come all the way back, feed it in here, nothing. What if I fed it in on here? This pin right here on this tube. And basically feed it into the plate of this tube. You should transform through here, tune here, and carry on, and I will be isolated away from this. That's a good idea. Feed it in right here on the plate side. I could even pull this tube out. Feed it into the plate here. Okay, sounds like a plan. How do I know which hole is the plate? Well, it's one of the two small pins. It's the one on the right. No, I can't do that. It's the one that I could find continuity to the B plus line all the way over to this capacitor. So if I can find continuity from one of the two small holes on this socket over yonder, I will have found it. Okay, back to the radio. So look at the radio and I've already lost track of what was I just doing. So I want to, moving back in the radio, yeah, this radio moves this way, the schematic moves that way. That's enough to confuse me right there. This is the tube I want to pull out. I want to identify the plate, which I'm pretty sure is this one here, but I can prove it by looking for continuity. What did I say? Between the pin in question and the, oh, that capacitor, it's underneath the power supply. Well, to one of these B plus lines, I think. Not that one, it would be this one. Maybe my theory's wrong. Oh, you know what's wrong? I'm sticking it in the big holes. Stick it in the small holes. 174 and and open. Definitely getting there. 174. So that's the plate. So I'm going to feed a signal into the plate and watch the excitement that happens afterwards. Just looking for an extender, socket extender. I don't quite have the right thing, so I gotta stick something in there, like a nice round thing, like this. That's good. That's got it. Okay. Signal in from here. I'm going to stick another capacitor in. This already has a capacitor in the feed line to protect my signal generator. Why not have another? Okay, gonna hook that up. Should hear something. Should be able to tune it. You're listening to the last stage. Should probably find B+ on that also, so I can measure for that. Double check that I've got it in the right spot. Okay. Away we go. B+ on the screwdriver. 120. Not quite what I was expecting. Okay, we're on restricted power though. Let's leave it there. Leave it restricted for now. We now take our signal, turning it down a bit. Hook her up. Nothing too exciting there. Oh jeez. I didn't expect that. I didn't expect that to drop in like that. Okay. So we're tuned to 528. We're actually tuned below the signal generator's too low. Bring it up. We should be picking it up around 900. Let's lower it. Now we're tuned to around 750. Nada. Okay, we'll go up. Power. Bingo. Back down. Back up. Pretty good. Let's turn it down a bit here. How do you turn it down? Like that. That's now the right frequency in the right place. So clipping that onto here was definitely throwing off the tuning, and I'm sure this is a much better approach. So all we're really checking now is this part of the radio. Sticking the signal in here, it's going over there. Okay, so just back the ship up one more tube. Let's make sure we got a nice strong signal coming through here though. Like that. Okay. Pull that out. Take this tube out. Put it over here. Move the input to here. Seem quieter. Alignment issues. Okay, so we got a good deal happening there. Okay, so I've turned the signal down further. Should move back further now. So out. This tube forward. Signal into the plate. It's kind of scary when it dropped right through and hit something. Okay, let's try tuning the radio. Pretty sharp, but basically not getting much pickup in strength as we move through these stages. A little bit. So there it is. Put this tube back in, we should be able to feed the signal right into the antenna and hear it again. It's pretty hummy, isn't it? Sounds pretty hummy to me. Okay, put this tube back in. This, of course, was the one up here. So one tube I tested low. I wonder if it's this one. Okay, let's up the signal strength. I think this tube's a dud. Right on the antenna. Oh, I need another 226. Okay. 226. Go hunting for one. The only conclusion I can really reach here is that this tube is not doing it for us. You know another way to verify that? There's another way. You pull it out. Pull this one out. Oh, before I do that, let's just make absolutely sure. Ooh, I don't like that. That's not good. Come on. There. Okay. Pull this tube out and put in the one I now suspect may be a bad actor. That should go silent. Good. Would have disappointed me if it kept going. Okay, this one in. They warm up pretty much instantly. Nothing. Well, this tube. This tube's the bad guy. Oh boy, do I have a 226. The number 26. Funny, I tested the tubes, and they all worked. That's how I remember it. There you are. That's proof positive, isn't it? Okay. Well, I don't know what to think about my old tube tester now. I got to get another one of these. Probably drop this guy back in the tester again. Okay, let's try it again with this old tester. So this is all set for 226, 1.5 volts, 67 here, goes into D. D26. Switch is off right now. Switch on. My left, because of the moisture problem I detected with the moisture showing up on the back of this glass here, I took this outside yesterday and left it in the sunshine. Just I don't know how effective that was, but okay. Switch on. Voltage about right. Didn't check it for shorts. Warm up. I don't know if I heard some sounds out of that or out of my stomach. Test. Oh, it's going up. No, look, it's going to be in the pour. Let me hold it down here. It's falling back a wee bit. It's really in the pour zone, isn't it? Pour. Okay. Let's try one of these ones that appears to be good for comparison. Finding out now if this tube tester really does the job or not. Put them in. Didn't check for shorts, but not too worried about that. And push the button. Good. Isn't that something? I mean, this tube tester is from like 1935, and as far as I know, nobody's ever done anything to it. I don't know that for sure, but just plug it in, turn it on, and put it to work. Okay. Well, this guy is the source of our problems. That's how it appears to be. Great. Here we go. Okay, I'm gonna have to find a 26. Yikes. I don't know. Go looking. Thanks for watching, and I'll carry on again tomorrow's shop session. See ya.